Great. Welcome, everyone, and thank you for inviting me. So, Vanya, I am from Hampton, Iowa. I am also an agronomist with Albert Lee Seed at Albert Lee, Minnesota, in southern Minnesota. And so, Hampton, Iowa is my husband and my farm, and Albert Lee is about 80 miles north of us. So, a little bit different topic than you often see, and so we're going to go down into some basics, but I want to bring that into why growth stages and knowing how plants develop can be related back to management. So basic, small grain growth types. We have winter types, spring types, and facultative types. We have winter wheat, barley, and winter rye. There is a winter oat that overwinters in the southern U.S., but does not overwinter in the upper Midwest. Spring types, wheats, oats, and barley, as you're aware of. And facultative types means that they do not need cold temperatures for vernalization. So some wheats and some barleys can be planted either in the spring or the fall, same variety, and make seed either way. When they're planted in the fall, they tend to yield more higher than when they're planted in the spring, but that's the definition of facultative, if you hear that term. Just a really quick review of wheat productions in the U.S. This is a USDA map, but you look at a lot of wheat produced in North Dakota and in Kansas. And the lighter green, you see Wisconsin, sort of part of the eastern corn belt there. But let me take a look further. The reason there's so many disparate areas of wheat production is because different types of wheat that are grown there. Now, what you see missing is these are maps are developed from crop reporting of plantings. And so Iowa grows very little wheat. Doesn't mean we can't grow wheat. But then the question becomes, if you look at the green dots around Kansas, Oklahoma, that's hard red winter wheat. And you look at the dots up in the Red River Valley of Minnesota, that's hard red spring wheat. And then you look in Illinois, that's soft red winter wheat. So the question always comes for Iowa, which wheats are best to grow here? And there's no hard answer on that. It hinges somewhat on market availability. With oat production, this looks a little more centered on our upper Midwest, and Iowa, we know traditionally has been a heavy oat growing region. We still are fairly dominant in oat production, and we could be more so. With barley, barley is grown farther north and farther west of us. In part, barley does not like humid conditions as we seem to have as you move farther east into the Corn Belt. Now, the reason I'm showing these maps, what does this have to do with development? Just to relate back to why these different small grains are grown where they are typically, and that doesn't mean any of them can't be grown in Iowa, Minnesota, Wisconsin. So with rye, I don't have a map for you. USDA hasn't prepared a map because we know cereal rye is being grown now throughout the U.S., largely for cover crop seed, but we know for other purposes as well. So when I talk about small grain growth and development, we're going to talk about all four species. And don't be frustrated when I talk about a developmental stage. This holds for all of these four small grains: wheat, oats, rye, and barley. It holds whether they're planted in the winter or the spring, although the dates of the developmental stages might be different depending on where they're planting. The same stages are experienced by all these species. Again, if I show you a graph on barley, that same thing applies to oats and wheat. And where there are differences, if any, I'll point those out. So why does it matter that you know how spring grains grow and develop? Just like with our other crops, well, more so than with some other crops. We know that temperature is important in all crop growth, and day length is more or less important. With corn, day length is less important. For soybeans, it is, and certainly for small grains, they are long day plants. So the development is driven by both day length and temperature. So you Iowans, and even those of you who maybe from the fringes of Iowa, will know about how a corn plant develops. John Hanway at Iowa State developed these definitions in 1966 that we know there are vegetative stages of corn and then tasseling. Then we move into the reproductive stages. And these have implications for when certain herbicides can be applied, when they can't be applied. We know now we're looking at V4 and V5 in those vegetative stages, perhaps for interseeding cover crops. And then we know the reproductive stages. These are important to know if the crop is damaged, the impact it might have on yield. So the same thing has been done for small grains. And I don't know what's happening with my slides here, but the small grain growth stages, how they look a little different than corn. They're both grasses, but germination and emergence would be the same, the seedling stage. But with small grains, we have tillering. You plant one seed, but you get more than one seed head, and that's because tillers have formed. There's the tillering stage, and then we move into stem elongation and jointing. This is a similar pattern you see, for instance, with forage grasses. Get to the boot stage, heading stage, then flowering stage or anthesis. And that's when the anthers that carry and distribute the pollen are extruded from the head. And then you start into grain filling, milk stage, dough stage, and ripening. So key production operations with small grains. We've got planting date. When should we plant? How much should we plant? We've got practices to optimize tillering, and this is key to small grain yield. If you only have one seed head from that one seed, you will not optimize yield. So we want to optimize tillering. Get as many as we can, at least based on the genetic capability of any given species and any given variety within that species. Nitrogen fertilization, when do we do that for optimum yield and grain quality? We've got grazing that often happens with small grains. For some of these, we're doing an early forage harvest, others later forage harvest. Timing for fungicide applications, when should we be doing that? Rolling rye for mulching, this is based on plant stage. What about later forage harvest? And then, of course, grain harvest, when we've reached the hard dough stage. So as I said, small grain growth and development is driven by both day length and temperature. These temperatures for germination here in the first part of this graph were derived largely from greenhouse and growth chamber studies. So if you look at them, 37 to 40 degrees Fahrenheit for wheat, 39 to 41 for oats, 38 for barley, 37 to 41 for rye. There's some slight differences, but if you really look at them, they're really not different. These are so close as to I just about feel like the temperatures for germination are the same for these four small grains. Now, a lot of people's experience will say rye will germinate at colder temperatures, just above freezing. And I think that may be true. I'm reporting here what's been documented, again, from laboratory and greenhouse studies. But generally, it's right around or under 40 degrees is when we're going to see germination. Now, the growing temperature ranges, again, these are derived from growth chamber studies, and most of these are a minimum of 32 degrees. Now, the rate at which they'll grow, rye will grow a little more, just above 32, 33, 34, because you've seen it green up in the middle of winter. But all of these will grow just about down to minus 32. Now, the wheat here for top level for growth, at 70 degrees, wheat does not prefer it to get much warmer than that. And you saw the wheat grown down in Kansas and Oklahoma. Now, one thing about small grain crops, they're sometimes considered drought and heat avoiding crops because they complete their life cycle largely before the temperatures hit those high ranges in midsummer. Now, that's dependent on early planting. So that's why we can grow wheat farther south, but it's out of the field before we hit those. In Kansas, it's out of the field before we hit July and August. The point I feel for this slide, as much as we want to know what are the differences between rye and wheat and oats in their growing temperatures and response, they're not much different. So staging methods. As I showed you, Hanway in Iowa did how a corn plant develops. So there are three main staging methods for small grains. And as you look at different guidelines or spray at this level or harvest at this growth stage, it will differ depending on what stage the writer was using. So Feeks is a stage that was best known as the most widely used. And I'll just show you a little bit more about these. The Han system focuses mainly on leaf production stage of development, and this is not widely used. I see it rarely in literature or certainly in production guidelines based for farmers. But Zadok scale is another one that's fairly widely used. It provides more detailed information during the early stages than Feeks does. And interesting, this is just different places. I believe all of these were developed in Europe, where small grains, in Northern Europe, where small grains are a primary crop, whereas we developed the corn guidelines, growth development guidelines in the Corn Belt. So here's a comparison of those three methods. So if you look at the plant stages along the left-hand column of this, and again, Feeks is in the center. They just are a numerical stage and that are assigned, based on days and growing degree days between the different stages. Again, Feeks is the most widely used, and you'll see not much emphasis put on those early growth stages, 1, 1, 1, 1, up until the third leaf stage, and then more into the reproductive stages. And I think this is most widely used because these post-tillering stages are more important for different management strategies. Frankly, depending on who uses it, as long as they match it up to the proper growth stage and to the management practice, it doesn't matter which one we use. But you notice Hans doesn't even go beyond flowering. So you'll typically see Feeks used. So here's winter barley. And the growth stages, GS, are those vertical dotted lines you see on this graph. So they're numbered. And this is the Zadok scale. Along the bottom is thermal time with, so these are growing degree days above, these are days above 0 degrees centigrade or 32 degrees Fahrenheit. But they're just the growth stages I've shown you before. Leaf emergence is a long period. Tillering starts shortly after leaves emerge. So winter barley or winter wheat, soon after those leaves emerge, you start to get tillers. And you see the growth stages, 31. Growth stage 39 is right where ear formation starts. Now again, ear formation in Europe, they call a head, small grain head, that we call in the US, they call it an ear. So just the progression of growth stages here based on degree days. So I'll go back. In a winter grain, we'll need vernalization in order for it to become reproductive the following year. And that happens sometime after or sometime before GS or growth stage 31. So let's talk about vernalization. Vernal means spring, of course, and vernalization is to make spring-like, to make a winter plant behave like a spring planted plant. So vernalization is a combination of low temperatures and the duration of those temperatures. Vernalization influences active meristems. So this is the part in the plant that have actively growing cells. And that meristem then becomes sensitized to day length the following spring. So vernalized plants then can respond to lengthening days and the increasing temperatures in the spring following the vernal equinox. And that allows it to switch to reproductive growth. So if you take a winter rye and you plant it in the spring, it does not become vernalized. So even though you get to lengthening days and increasing temperatures, it stays vegetative. So the winter type grains require vernalization. This question comes often, particularly when we're forced into falls where rye is planted very late. what do we need to vernalize any winter grain? How late can we plant it and still get it to perform the following spring? A fair amount of work has been done with this, and it's not exactly conclusive. My guess is there are ranges among varieties within these species. But let's look at wheat on the left-hand column here. So temperatures have to be between 30 and 52 degrees. And I'm thinking that's a really wide range of temperature. Can you really vernalize a plant at 52 degrees Fahrenheit? That doesn't seem very cold, but you can. The period takes about 50 days. Now, Ohio did some work that to me, the results were very surprising. They went at higher temperatures, but at higher temperatures, at higher temperatures, it took longer periods. No, that is what you would expect. Barley takes the lowest number of days required for a winter barley. So we're talking all about winter grains here, 30 to 45 days. And the researchers in this study did show that with only 15 days, that was not enough to vernalize it, and the following spring it remained vegetative. With rye, I think there's a question mark. So it says you can do this with warmer temperatures than you can with barley, winter barley, and it takes 30 or more days. I know there are people who say, oh, I can plant rye in February and it'll vernalize, and it may well do that. So remember I said the active meristems have to be influenced by the cold temperatures. And for any of these winter grains, once they swell in the ground, they swell with water and they start the germination process, they have an active meristem. Those cells have made the changes to start in a growth phase, hormonal changes. So plants can be vernalized even though you don't see a root on them, as long as the seed has swollen, started to germinate. So with rye, I think that's why we do see it vernalized almost no matter when it's planted. It's a pretty tough plant. But 30 or more days, and I believe that case, even though they found this in lab situations, I believe that's the case in the field as well. But that's pretty easy to achieve. Even if you plant rye in November and it swells, it can easily be vernalized before the following spring. So the growth stages of wheat, barley, and rye are very similar. Of course, they all have a spike-type seed head. And just a visualization here is what it's going through. Those of you that have grown these are familiar with these, but you see those leaf stages. But early on, if you look at the top of this graphic, between the 3-leaf stage and 4-leaf stage, usually tillering begins. Now, for winter grains, we want that to be in the fall. We want tillers in the fall. A well-tillered plant in the upper part of the graph there. And then after tillers have formed and enough growing degree days have elapsed, then you start jointing or formation and elongation of the future seed head. So wheat leaf structure, just here to look at the blade and the sheath. You guys have seen this with all grasses, but this is related to as we move into the vegetative stages. And the vegetative stages, this is what you're going to see, but you want to watch the leaf blades as you move into the reproductive stages, because we're looking for that final flag leaf or ear leaf. And again, ear leaf in European terms. Tillering at notes, so we're looking at a spring plant here. The phenomenon is not any different. And you can see on the right-hand side, that's a main stalk with 2 tillers forming. Each of those can form a seed head. So a similar graphic here that I showed you for winter barley. And if you looked on the winter barley graph, this leaf emergence was a little longer time period, just because that's in the fall. This is spring planted oat growth. And we're starting in March. Now, the months along the bottom of this graph will move depending on where you are. So sometimes we sell oats to growers in Oklahoma. So these dates are going to switch way to the left, working into February. But leaf emergence is a very elongated period, but tillering starts not long after. We just saw that in the graph with barley as well. And the thing about tillering and stem elongation, tillering stops once that stem starts to elongate, your future seed head. So those are keyed change between vegetative growth and reproductive growth. And I think you can see this. Oh, here, I think you can see my pointer. This date here is pretty much a cutoff where the first node is detectable. And this is happening usually in May for our oats grown in Iowa or the upper Midwest. So panicle formation, a little bit later on, those are forming, of course, when that head is still within the sheath. Flowering is a fairly short period. And flowering can be a vulnerable period for disease infestation. Grain filling starts not long after flowering. That plant is cranking along. Once fertilization has occurred, we start accumulating carbohydrates in that grain head. And then the ripening, here we're moving through, sorry, my pointer. So here we're moving through obviously the milk stage and the dough stages. And in here at ripening, we're right at the hard dough stage and then into ripening. So typically we're ripening oats toward late July. One thing to note here, if you think of planting day, and I talked about planting in Oklahoma, seems almost crazy that you could plant oats and you can grow oats in Oklahoma, but they can as long as they plant early enough. I'll go back to small grains are heat avoiding crops. That was not supposed to move. Oh, goodness. So you want to plant oats as early as you can to start the leaf emergence, start this process, let's say cranking, so that we can achieve grain fill and harvest before the hottest weather hits. So tillering is key, and it's not always a long period. You've got a little longer the earlier you plant, because you've got a little longer before the long days start affecting the reproductive stages of growth. But tillering is affected by seed rate, by temperature, by light, and the availability of water and nutrients. Well, a lot of this is true for a lot of plant growths, but plant growth factors. But tillering, you will get more tillers with cooler temperatures, plants growing through the stages. There needs to be light at the base of the plant. And of course, we need to have available water and nutrients. We're not in control of how much water we have unless we have irrigation. But with nutrients, we are. So oats do require 90 to 100 pounds of nitrogen to produce a crop, and that nitrogen can come from soil mineralization, can come from manure, can come from fertilizer, and can come from residual nitrate from a previous crop. But you need that N available early before stem extension if that nitrogen is going to help you increase tiller numbers. So the maximum shoot number almost always exceeds the final shoot number. And so later forming tillers often die off as their competition. Now, with a lighter seeding rate, you're going to have less competition. With a heavier seeding rate, you're going to have more competition. So a little die-off is not necessarily a bad thing. If you look at progressive tillering here, again, the dates are along the lower axis here, and the tillers per meter squared. So the first tiller there in early on in planting, early April, up to 9 tillers formed per seed, per plant. Until you see the first node detected is when we see the maximum number of tillers, and then they tend to drop off. So this is normal plant development. This isn't bad, but we certainly want to start with a higher number. So we drop off to a number that can optimize yield. So from the time the panicle is completely emerged, we've just about got down to where we're going to be. But we've lost about a third of the tillers here with oats. So tillering in wheat, and again, this can be spring or fall, but you see tillers 1, tillers 1, 2, and 3. Tiller 3 hasn't emerged yet. We've just got 2 tillers here, but it looks like a lot of leafy area. So I've commented about planting date, both for spring and winter grains, but this is a great study from Kansas. I love this, but I love that I wasn't a graduate student on this study. Winter wheat in Kansas. So the optimum seeding dates for winter wheat resulted in more tillers produced in the fall than the spring. And that's what we want for higher yields. With later planting dates, there's just not enough time and temperature in the fall for many tillers to occur. And I think this is probably most important in Iowa when we think about winter rye. So with later planting dates, we'll see more spring tillers, and more of those spring tillers will follow this same pattern as with winter wheat. Will produce more grain than the fall tillers, only because there were fewer fall tillers. So key here was weight of both the grain and the straw for productive fall tillers was greater than for productive spring tillers. Productive meaning they produced ahead. So you got more weight from those fall tillers than you did from the spring. And the kernel numbers were always higher for fall tillers. This, like I said, I think this is a great study because we want to maximize fall tillering with our fall winter grains, wheat, rye, and those of you who may be growing winter barley. And so that hinges very much, as I said earlier, on planting date. There's an optimum range, and in Iowa, that's usually the latter half of September. It's some nitrogen available, maybe not all that the crop's going to need, and certainly water availability. But planting date is just key. So to enhance tillering, plant at the early range of optimum. You've got more growing period left for tillers to form, and you know that you're not going to get into the reproductive stage with the winter grains. Assure adequate end fertility early before jointing. And so in most of these crops, that's probably in the 40 to 50 pound range. Wheat is a higher nitrogen user than oats, but winter wheat, winter barley, winter rye are all fairly high in nitrogen fertility users. Physical disturbance can enhance tillering. Maybe anti-intuitive, but you're irritating that plant, you're stimulating that plant, you're stimulating the crowns to know that, oh, I need to get going here. Now, this is not a very scientific way to describe that, but in fact, disturbance of the crown stimulates more tillering. And some growers will go with a tine weeder and just drag that out there to stimulate that. However, and this is why we see fall grazing and winter grazing on a lot of winter grains, particularly as you move south of here. But before the end of the tillering stages, as we get into spring, you need to get any grazers off before you see the first node of that jointing stem. So seriously, I encourage you to be out there and pinching those stems and feeling for that node, because if you graze off the elongating stems, you're going to cut your yield. But grazing before that time does not bother it. And again, we see a number of Iowa growers grazing their winter rye and then taking it on to grain the following spring. Very touchy. So we talked about tillering, stem elongation, and jointing, but let's look at the nitrogen fertilization. Now I'm going to switch to oats, but again, don't get frustrated by me switching from one grain to another. This holds pretty much throughout the 4 species. So early on, germination, early growth through tillering, if you look at the left-hand side of this graphic, and we've got a photo of growing oats here, they're taking up 1.1 pounds of nitrogen per acre per day. And they'll take up a total of 67 pounds by the time that first node of that elongating stem. Okay, we're talking about that's a critical time for grazing or to remove animals for grazing. But about 2/3 of the nitrogen that's been taken up is taken up by this stage. So if you look into the next stages between first elongation, that first node detectable, and flag leaf, the rate of uptake has slowed. but it's only taken up an additional 12 or 15 pounds. And then from flag leaf, the rate of uptake changes, but it's a fairly short time because we're only taking up about another 20 pounds after that flag leaf has formed and is visible. This graphic will look like a similar one I would guess most of you have seen for corn. This comes from work that South Dakota did with oats for nitrogen uptake. And so if you look again at heading, designated by my little red arrow there, and then you move up the graph, by heading, nitrogen uptake is complete. And this has repercussions. Sometimes we have a hard time, particularly organic growers, ensuring that we get enough nitrogen to that corn. Manure applied in the spring before oats really is not going to be providing, may not be providing all the nitrogen you need. Let's say if you're following a corn crop with little or no residual nitrate. If you just, it's just because we're growing at a different length of time than, let's say, a full corn crop. So if manure is going to be applied to oats at all, apply it in the fall to let that breakdown start happening. The lines are designating then the nitrogen translocated to the grain, the stem, and the leaves. So the stem and the leaves, the grain is after heading, of course, is accumulating nitrogen being translocated to the grain, being incorporated into proteins, or it's declining in the stem and the leaves. And this, you well know, this is just to illustrate that fact. So this jointing stage, let's go back. This is Feek stage 6. The number is not particularly important, but the crop water demand increases at this stage. And about 25% of the total dry matter is accumulated by this stage. So it varies the importance of this stage. For crown rust and oats, this can be an important stage to look for beginning rust infestation or infection. And you can consider putting a fungicide anytime after this stage. There is a challenge in driving over the crop after you start jointing, because wherever the wheels go, you're going to damage those stems you drive over. But after this stage, you wouldn't be applying dicamba or 2,4-D. And these you can check. Any herbicides you might be considering using, they should have these guidelines on the label based on either the verbal stage, such as first note available, jointing, with those terminology, or by growth stages, typically using Feeks. So you want to complete spring top dressing in before this stage. Now with spring planted grains, I am going to separate the winter planted versus the spring planted. With spring planted, you want to apply your nitrogen at planting. I wouldn't come back and top dress. It's just driving over the crop, potentially driving over those elongated stems, as I just said. With the winter grain, we'll typically see best response, yield response to splitting that nitrogen application. And as I said, 40 to 50% in the fall, 40 to 50% in the spring before stem elongation. So the flag leaf stage, we're moving on through the reproductive stages now. Up until this stage, we're scouting for crown rust, as I mentioned. Any time from stem elongation up until the flag leaf stage, be scouting for crown rust. So the worst disease we experience for oats in the upper Midwest. And you can apply fungicides. Most people do this by ground, can be done aerially. You get better coverage, obviously, with ground application. So some results from fungicide use on oats, and this is for prevention of crown rust. A somewhat involved graph here, but let's look at the upper left-hand corner of oat yield response to fungicide. This was done at the Northeast Iowa Research Farm near Nashua. They took 4 oat varieties, Dion, Hayden, Horsepower, and Shelby 427. And the blue bars show yields with no fungicide, and whatever that color is, light orange, tan, buff, indicate the fungicide treatment, the response to fungicide treatment. The little asterisks you see there on Hayden and horsepower indicate a significant difference between the treatments. So fungicide did result in higher yields for Hayden and horsepower in this just 1 year. So with test weight, they also responded to fungicide treatment. If you look at, that's the portion of the graph on the upper right-hand portion. With straw response, they increased straw yield. And part of what's happening, of course, is they're maintaining integrity in that stem and the ability to better photosynthesize, send a little bit more to the grain, and to stand better. And there was a height response for Shelby 427. So there's not a consistent response to fungicide for crown rust, but there tends to be. And of course, the heavier the infestation is, the better the response tends to be. Now, horsepower, if you go back to these varieties, horsepower is a variety with very little resistance to crown rust, whereas Dion at this period had much better resistance. So that's part of the story as well. If you're planting a variety with little crown rust resistance, this stage, somewhere up to flag leaf, is a time to apply fungicides. And that's based on scouting. If you have a variety with high resistance and you don't notice it, probably no need to treat with fungicides. So it's a multifaceted management decision whether or not to treat for crown rust. But stage is important. If you wait to treat for crown rust much past the flag leaf stage, the infestation often is pretty well underway. So let's look at the boot stage. I'm never exactly why this is called the boot, except I know in Britain, the boot is the trunk of your car. The head is enclosed in that sheath. Is that related to boot? But this is the best time. If you look at timing of small grain growth development, this is the best time to harvest for forage if you're looking for high quality and a compromise between high quality and high yield. It's 23% protein, highly digestible at this stage. And if you take this grain off at the boot stage, let's say in Iowa, this is often late May, whether it's a winter grain or a spring oat, you still have time. You can double crop. So when you're using small grains as a companion for an underseeding, that releases that underseeding to get this off in the boot stage, it's often chopped off so that it doesn't have to sit there in a windrow on your new seeding. But beautiful quality forage at the boot stage of growth. So the heading stage, once that head has come out of the boot or out of the trunk, is continuing to elongate, and you can see the head. So this stage is extremely important for fusarium head blight. This is the period at which fusarium can enter those florets. In the spike, you've got those spikelets and you've got florets there. When they open to extrude the anthers, that's when they are susceptible to infection by fusarium. Fusarium can be splashed up from the ground surface or it can be blown in, but this is the critical time period. And Scab Smart is a program that indicates how prevalent scab may be in our area. And if weather conditions are such that it's going to be prevalent, this would be the stage that you would treat with a fungicide for fusarium. Now, organic growers don't have that option, and so there are other strategies to manage fusarium. So ScabSmartStart.org is a tracking tool for fusarium head blight, and it's an easy thing to take a look at because and it's a good indicator because scab will tend to be prevalent farther south because of warmer temperatures before it hits Iowa. And so we can see if it's coming. And again, you have to monitor the weather conditions. But it is a good indicator. Is this going to be a hard year for fusarium? And 2024 certainly was. So go back to these Feek's growth stages. This heading, you'll often see this. Oh, and this 10.1, 10.5 is a critical stage. Okay, again, you want to have all your fertility applied by then. We know this opens it up to susceptibility. For rye, this heading stage opens it up when those flowers are open, makes it susceptible to both scab infection and ergot. So I'm just going to leave this on the screen just a little bit. Do you look at the Feek's growth stages? And here we're giving you whole numbers, but just some of the important management considerations that go on at the different stages. I talked about early nitrogen applications early on to enhance tillering, stages 2 and 3. That's still in the leaf formation and tillers are starting. For wheat, again, with 5, you can top dress nitrogen applications. So 6, again, when we are starting elongation, would be cutting off that nitrogen. And if you're going to top dress, this is really important because the plant goes through these stages pretty quickly. So you need to be ready. If I'm going to top dress nitrogen, am I going to do it? Is the co-op going to do it? I need to get them lined up because you're going to go from vegetative to reproductive very quickly once you hit these stages. Continued scouting through the growth stages. So 8 and 9, this is for wheat, but I can apply this to oats as well. You can apply fungicide to protect the flag leaf anytime before flag leaf for crown rust. And so there's some other diseases available that we don't often deal with. Check for armyworm feeding at 10, but at heading then, again, I'll just reiterate, this is the time and you've got to be ready. If fusarium is in the news, is on Scab Smart, but that's the time to be applying that. Now, I talked about other management strategies for disease. It's not just spraying fungicides on small grains. And if you look here, I've got the major diseases, top major 3 diseases in orange on the left-hand side, and then management strategies. With oats for crown rust, it's largely variety selection, and that's what we have at our availability for oats. Crown rust is blown in from the southern US, so rotation is not a large factor. But variety selection, breeding for resistance is important. And on this graph, fusarium, not a big problem, but it was in 2024. And we almost didn't see that coming. So fungicides are a strategy, but that's tough because there's not a lot of breeding effort that goes into resistance for fusarium and oats. With barley, other strategies besides just fungicide, let's say at Feek's 10-5 or heading, crop rotation is extremely important, as well as variety selection. For wheat, crop rotation is I would say the top strategy. Crop rotation and variety selection are top strategies, with fungicide being, I'd say, the third method of approach to managing fusarium. Leaf and stem rust, again, there's been breeding for resistance. Crop rotation, very important. And for rye, again, ergot, variety selection, and crop rotation are extremely important in management, with fungicides being a third line of attack. So again, from a plant development strategy with rye, avoid traffic after that jointing begins, because driving over that, so even for a fungicide treatment, if you could do it by air, if you can do it with a drone, much more desirable, because after joining begins, you're going to slow down the development of the plants you drove over. They're going to head later. Those flowers are going to be open later, and you increase the time, early flowering plants and later flowering plants, that those flowers will be open and be able to accept ergot spores. Just a quick review of the growth stages. Again, I think you're familiar with them already, but the one that is so different for small grains compared to corn and soybeans is that tillering stage. And such a big determiner of yield. We've got to have heads to get yield. Just some resources here, and I can leave these on the screen. if you want to look any further, or certainly you can email me if you have any further questions, or we can take questions now.
All right, thank you, Margaret. So yes, Margaret's correct. If you have questions, you can go ahead and type them into the chat box, and we have a few minutes here to answer them. So I'll go ahead and read out the first one to you, Margaret. Can you think of any situations of when planting cereal rye in the spring would be advantageous despite it not having been fertilized?
Oh, certainly. And there's been some work done on this, both with some university researchers and with PFI farmers, of using that spring planted winter rye as a weed suppressor with soybeans. They've also looked at that to suppress weeds with dry beans. So the plant gets up to be about 10 inches tall, and then again, a very, very unscientific term, it stalls out. So it stays vegetative. It doesn't do much more than that. It only puts on a few tillers and then it never goes reproductive. So yes, you can also use that winter rye or winter wheat as a companion to establish a hay crop. It'll be less competitive than, say, a spring planted oat. So yeah, there are a number of reasons there are a number of situations we can use that tendency of plant growth to our advantage.
Thank you. Is Albert Lee Seed working on seed selection for early tiller producing grains, or are there seed selecting partners in the Midwest doing so?
It's a great question, and I don't know the answer to that. We do not develop our own varieties. And so for oats, we largely have worked with universities in the upper Midwest, South Dakota State, University of Wisconsin, University of Minnesota, University of Illinois. And so I don't know if that's one of their selection criteria. Great question.
Okay. I don't see another one at the moment. So if you do have a question, the chat box is at the bottom of your screen. Feel free to type one in there. We've still got about 10 minutes of time worth to answer some questions. So if you've got one, let us know.
And I just want to put my email up on the screen and telephone. If you have other questions about small grains, production, fertilization. One thing just to review, there always comes a question of, if I want my plants to tiller as much as possible, I should plant fewer seeds. And that's true. Modern wheats, however, have been bred that they only produce about 4 tillers. So you have to seed a minimum to maximize the number of seed heads out there. Now, a hybrid rye will produce many more tillers per plant. With oats, kind of the sweet spot is you probably want not much more than 2 to 3 tillers per plant. So the primary tiller produces the heaviest seed with the highest test weight. And the subsequent tillers, the seed can be, it's just slightly later. I mean, we're talking half a day, if anything, but they tend to be slightly lighter in test weight. And so if you have 5 or 6 or 7 tillers in oats, that will tend to bring your test weight down. We do have data that shows the heavier you plant, the higher the test weight, as well as the earlier you plant, the higher the test weight. And those plant tiller, I said in response to nitrogen, light. So light has to hit the crown of that plant for tillers to form. And so the heavier you seed, the fewer tillers you have. You can only get so many crammed into any given space. But that's okay because those few and earlier tillers tend to produce heavier seed.
Thank you. We did get a few more coming in. How early is too early to plant oats? Say in central Iowa, for example, in this example.
Oh, yeah, here we go. 2025 looks like it's going to be an early spring. And we did face this 2 years ago as well in 2023. Don't have an exact answer for that. Oats are pretty frost tolerant. They're very frost tolerant. But what they're not tolerant of is sitting in wet ground before they emerge. The swollen seed with maybe only a root with a radical shot out there, they're not very tolerant of long, cold, wet conditions. Once the leaves are above ground, they are. So the guideline for oats has always been plant as soon as you can, as early as you can get in the field. Go, go, go. Well, 2 years ago in February, it was balmy, balmy. And then March turned off kind of cold again. If you have a 30-day forecast that you can get those oats up and out of the ground, we can certainly push planting in Iowa. And again, Iowa's different between northern and southern anyway, but into very early March, southern Iowa maybe or late February. But I know our weather patterns are changing. What we're seeing is more variability throughout the growing season, not just in the spring. And so just because we have a warm February, it may turn off cold again. And just to repeat, the vulnerable period is if it's swollen or maybe just shot a radical, and then it turns off cold again. They can rot. So I think we can push it earlier than we have before due to our change in weather pattern, but February makes me nervous.
All right. What is the best way to manage weeds with spring wheat?
It's a great question, and particularly for organic growers. Is this grower organic? Because there are herbicide options for conventional growers. But wheats, as a little background, wheats were bred, and if you remember the whole period with Norman Borlaug working in the tropics, wheats were bred to be dwarfed so that they could carry more weight on that seed head. You could increase the yield and they wouldn't lodge. So wheats are short. That means they allow more sunlight into the canopy. It means they're more weed prone than, say, an oat crop. So with a no herbicide option, the best way again is early planting and heavier seeding rates. They're all short. There's not a lot of variety between wheat heights. We see more variability among oats than we do among wheat. But what you need is early plant coverage out there. You want to cover that ground as quickly as possible. And so it's a little, don't be apprehensive about someone from a seed company saying plant more seed. But again, for organic growers, I was told this by an older farmer quite a few years ago, but the best weed management strategy is seed. You want a thick, uniform stand early, and that's your best management against weeds.
Okay, thank you. Another person wants to ask about fall grazing wheat. Is there any research showing the yield impacts on grazing versus not grazing and versus different grazing times?
There is, and I don't have that at my fingertips. There's word from Kansas that shows some yield increase from grazing, and I think that's due to the increased tillering. One thing that has occurred to me is they can do this more readily in Kansas and Oklahoma, western Nebraska. We have to be a little more careful here because we're wetter. And if we have ground, it's easy to damage those crowns. And so important guidelines for those drier areas where they graze a lot in the wintertime, it's very, very common, is, as I said earlier, get the animals off before it joints, starts to set the head up. But for us, you've got to watch the soil surface. When the ground's frozen, it's fine. I don't think you're damaging those crowns at all. But when that ground is thawed, that's when we need to get animals off there. So whether we're increasing yield with the grazing, maybe. I can't say for sure, but I know we can damage it if we pug that or damage those crowns in damp soils. So frankly, it's a little higher level management than I think folks have to exercise in drier areas.
We've got a few more minutes and it looks like just 3 more questions. So I think we can do it.
Great.
What crop rotations do you recommend for people growing small grains? Is this different for organic farms given the increased challenges in disease management?
The best response in small grains in the upper Midwest is following soybeans. We know that the soils following soybeans are mineralizing nitrogen in a different way or more rapidly than they are following corn. We've got less residue to hamper soils warming in the spring. So a very successful rotation is corn, soybeans, small grains. With the small grains, then you also have the opportunity to get a nice cover crop and fix some nitrogen for the following corn crop. Now, there are people who will do this another way, or corn, soybeans, small grain, and then establish a hay crop. There are people who will follow, small grains following corn. It's almost, it's very difficult. I don't want to say almost impossible, unless it's silage corn, to plant winter grains in time following corn. You can manage that with soybeans, and in fact, you can no-till it with soybeans, whether you're organic or conventional. Small grains just don't like corn residue. So again, if you're taking corn silage off, you might be able to do it, or if you're baling corn stalks, but then it's so late. I've observed small grains doing 10 to 15 bushels better following soybeans than following corn. And in addition to the fact that you need to supplement more nitrogen from elsewhere than you do following soybeans.
Okay, thank you. Our last one, this person has noticed that barley has a very specific vernalization temperature. And their question is the number of days required for vernalization based on a certain number of hours in the day at approximately that temperature? Or does the temperature just need to reach that 34 degrees at some point during the day for 30 days throughout the winter?
This is a really great question. And I've had the same question about when we calculate growing degree days. When we calculate growing degree days for anything, corn rootworms, anything, we do that just that the day touched that temperature. We don't monitor how many hours. And I don't know the answer to the question, but I do know that when we've calculated them, it's just based on the day reaching that. But this is in part why, clearly if the day spent 12 hours at that temperature versus 1, I think there would be a difference in the days to vernalization, but I have never seen that documented. I mean, it's a great observation. It's a great question.
Mm-hmm. All right. Well, that is it that I see for the questions, and it's 1 o'clock. So I want to thank you, Margaret, for joining us and giving this great presentation today. We really appreciate it. And for everyone else for tuning in and getting to learn a little bit today. So thank you, everyone, for coming.
Thanks all. Good to be here.
And Margaret, if you want to stay on for just a minute.
Sure.
Do you mind stopping the screen share real quick?
Right.